Hello everybody. So today we'll see computer networks. Already we have completed operating system and data structures. Now we'll start with the computer networks. So here there are 5 problems. We'll try to solve one by one. First problem, using RSA algorithm, if P is equal to 13, Q is equal to 5, E equal to 7, find the value of D and cipher 6 with EN key. So let us do this problem. So this uses a RSA algorithm. So let us try to solve this. So here we have given, using RSA algorithm, we have to find out the value of D. So given P is 13, Q is 5 and E is 7. So we know that in RSA algorithm we need to find the value of N. So we need to have a knowledge about the main formula points of the algorithm. So first we have to find out N. What is N? N is modulus of encryption and decryption. So N is P into Q. So what is P into Q? 13 into 5, which is 65. Next, psi of N, which is the Euler-Tolerant. Phi of N is Euler-Tolerant. Here the value will be P minus 1 into Q minus 1. So what is P minus 1? That is 12. Q minus 1 is 4. So 12 into 4 is 48. So next we have the condition. So what is the condition? That is E is the encryption key and D is the decryption key. So here E is given. They are asked to find the value of D. So what is the formula here? E into D mod psi of N equal to 1. This is the condition. So using this formula we can find out the value of D, right? Because E is already given as 7. E value is given as 7. So substituting this value, so 7 into D mod, what is psi of N? Psi of N is 48 equal to 1. So what value of D will give 7 into value mod 48 should be 1. So 7 to 7 is 49. So the value of D is 7. So value of D is 7. So we found out what is the value of 7. Now they have asked to cipher 6. That means we have to find out the cipher value. So again there are two formulas to find the cipher value. What is the formula? That is the plain text value, encryption key, the power of encryption key, and mod N. Okay, similarly, the formulas, if you want to find out what is the plain text, given the ciphertext, you have to decrypt C to the power of D mod N. Here we have given the value of you have to cipher the plain text is given and you have to find the cipher of this plain text. So C is equal to cipher 6, plain text is 6. 6 to the power of E is value is 7 mod N. What is value of N? Value of N is 65. So 6 power 7 mod 65. So what is the value of 6 power 7? So you have to find the power of 6 of power 7. So I found out the value. It is 279936 mod 65. So this turns out to be 46. Hence the value of the cipher is 46. Okay. Next we'll solve the second sum. An analog signal has a bit rate of 6000 bps, as bits per second, and baud rate of 2000 baud. How many data elements are carried by each signal element? So here we see that there is a given is a bit rate and the baud rate. So bit rate is 6000 and baud rate is 2000. So you have to use the formula, that is bit rate equal to baud rate into number of bits per baud. You need to know that bit rate is number of bits per second and baud rate is number of signal elements per second. So given is bit rate is given as 6000, baud rate is also given as 2000, and we have to find out the number of bits, which is the data elements which is carried by the signal. So 2x, so x is equal to 6000 by 2000, which is equal to 3. So it is 3 bits per baud, and I said 3 bits per baud. So the answer is 3 bits per baud. So next problem.